will be p plus 5 halves squared. And this will be 28 fourths, which is 7. We'll have p plus 5 halves squared equals 7. So that's the part that's completing the square. Now I started with a quadratic, and now I have a perfect square. So now the second part is using the square root property. The square root property is what tells you how to get rid of that. In other words, to get it out from under the square. So that means I'm going to do plus or minus the square root. So I have p plus 5 halves equals plus or minus the square root of 7. So p equals negative 5 halves plus or minus the square root of 7. Okay? Because now I have to get a common denominator between these two, put them together, all that kind of stuff. So you can do it by hand, or you can put out your best friend in the whole wide world, especially at this point. And I can say negative 5 halves plus the square root of 7. So negative 5 halves plus the square root of 7. Now we'll get negative 5 plus 2 square roots of 7 over 2. So this becomes negative 5 plus or minus 2 square roots of 7 over 2. That's it. Yes?
How did you get p plus 5 over 2 squared?
That's what I get when I factor that. This splits into 2 identical pieces. That's 5 times 5 on the top and 2 times 2 on the bottom. The whole point of this process is to make this split into 2 identical halves. So it's always going to be the square root of that. It's always going to be this number right here. Whatever you get when you cut that in half, that's what's going to go here. That was already there. In other words, you cut that in half, square it, and add it to both sides. But when you cut it in half, that's what's going to end up in your parentheses. Because this, remember, this thing is factoring. It's literally factoring like this. You know, in the back, it's 5 times 5, 25, 2 times 2 is 4. And then it's 5 halves plus 5 halves is 10 halves, which is 5. So it's literally the same kind of factoring you always do, just with fractions. But you don't have to do this, because your eyeballs should tell you it's always going to end up being that. Every single time. Every single time.
That's, so in that area, the P2 plus 5P, we FOIL there. That's foiling.
If you wanted to actually write it in parentheses and multiply it out, yeah, it would be foiling.
Okay.
To check and make sure you got back to the line above. Pardon me? It's that one you did for homework. I believe that would be 1.4. That was a week ago, lecture. You know. Crack kills, you know what I'm saying? Any others?
On the top.
On the top here?
Yeah, the half. The 1 over 2 times 5. Where'd you get the 1 over 2 from?
Oh my God, that's the algorithm.
Oh, that's. Yeah.
That's what you do every single time. Half the middle term. That's the middle term. Square it. Add it to both sides. That's on the list that I gave you of the steps to solving this thing. Step number 3, I believe. Probably.
person having a problem, but when I look at it online, the text, like,
You have to move it to Word.
Open it in
I
Word.
have to open it up in Word.
Not in I anything, unless you're gonna open it in
With
Word.
the box, I just click, I open it in.
No, you gotta open it in Word. But that should still show up okay, because that's just the text part. The writing should be screwed, because those are graphics. Yeah. But these are the steps right here. Like I said, the same steps. Scroll down, sorry. Now, the very first thing you should do, if this is a test question, is type that puppy just as it is into your Casio and see this answer. So you know where you're going. In other words, every single person in here, well, who has a Casio, which hopefully is all of you, but there will be holdouts. Every single person should know immediately that's the answer you're going to get. Because this, you can type in direct from exactly the first line. You can just go mode, equation, number 3, -4 in front of the square term, -20 in front of the term for the first, 3 for the constant, and there are 2 answers. So so that's why, you know, you do this and you say, oh yeah, I got the answers, but I did it a different way. Yeah, sorry. No.
Are we gonna show the work, right?
I mean, it's an advantage to have the calculator. It's an advantage to have a multiple choice test because it narrows the choice of answers. You know what I'm saying? In other words, if you're working a problem and your answer is not there at all, you seriously screwed something up, okay? I mean, but, you know, just having the answers does not mean you don't have to show work, especially this one, because the directions say, show me completing the square. Show me this method in particular. The only question on the test that asks you for a method. What I'm going to do today, which is about 6 problems on the test, the bulk of the test is what I'm going to do today. These do not say use solve by completing the square, solve by, they just say solve. So at some point you could do completing the square, you could use factoring, you could use the Casio and something else. I mean, I'll show you, it's a little different. But this one has to be done exactly like I'm doing it. It's completing the square, it's the method, not the answer. But obviously, if all I wanted was the answer, I can get the answer by typing. It's the technique of half the term, square it, add it to both sides. That's the technique that's important because we use it later on for graphing things. God forbid. Any other ones? Are you ready for help? Sure. You want me to do it, or you want me to, or you want? Oh, sorry. Okay, so I already have one of these isolated. So I'm going to go ahead and square both sides. And remember, there's only one of these on the test, but I'd say this is the longest problem on the test. So here I have x plus 4 here I have x minus 1, 2 times x minus 1 plus 1. I'll wait to see. After doing all those homework questions from this section, you remember how to do that. Okay. I ain't buying it, but I'll pretend I'm buying it. So move everything over here, except for the radical. So I will have x minus x. 4 minus 2 is 2. I can leave the 2 in, or I can divide both sides by 2. Did I make any mistakes yet? You don't know. I can write anything down. Complete crap, and you just buy it. Oh, Lord have mercy. Did anybody do this problem on their own?
Yes.
I copied it.
I got 4 equals 2 square root of x minus 1, and then I divided the 2.
No, I
out.
copied it wrong from here to here. These are going to cancel.
And I got 2 equals square root of x minus 3.
But, you know, that wasn't a complicated thing to spot, okay? That wasn't tricky. I copied the freaking line wrong, and you're still going, I don't know. Oh my God, you better at least read what I'm writing. You know, copying is a fundamental skill. It's not an algebra skill. So I can divide both sides by 2, or I can just leave it alone. I think I divided both sides by 2 when I did it in the notes. So I'll just leave it here to show you what happens. So this is 16. 2 squared is 4, and x minus 1. That 2 is going to get squared because it's outside the square root. It's not underneath the square root. What comes out from under is the x minus 1, but this is outside, so it's 2 squared, square root squared. So this is 16, 4x minus 4, that's 20 equals 4x, 5 equals x. And then I have to check. If 5 plus 4 equals 5 minus 1 plus 1. So that's square root of 9 equals square root of 4 plus 1. C equals 2 plus 1. And then, of course, put it down your pencil. You just have to remember to check it. Because it's possible that that wouldn't work, and if that doesn't work, then you have no solution. Because you'd have thrown away the only answer you have. And that was relatively short, unlike the other one, because the x's canceled out, so I didn't have to FOIL for a second time. Well, staring at me like, holy shit. Oh my God, you gotta start doing homework. Trust me, this is not a test you wanna wait till the last minute. Trust me. Oh Lord. You ready for something more gruesome? Now, this lecture today is going to show you what the real challenge with this test is. The real challenge on this test is not that any one problem is difficult. It's that there are a lot of different style problems, okay? And when you're doing them in homework, they're sort of segregated. You go into a section and you know that all the problems in the section look like this, and you can get into that pattern where you do this one and then the next one and then the next one. They're all the same. And then you go to the next section and they're all the same, and the next section. Well, what happens when you hit the test is obviously they're out of the sections. They're all mixed together. So now you don't have that little hint that you just finished doing 3 of these and now you have 1 more. That's one of the reasons I also give you a review sheet, because on the review sheet it looks like the test. They're all mixed together. There's nothing on the review sheet that tells you anything about what section they come in or anything like that, okay? They're just all mixed. And that's one reason you want to practice that review sheet more or less like it's a test. The idea of the review is not to do it with your book sitting open next to you and looking stuff up, because that does not help you on a test. The idea is to finish the freaking homework with the book sitting next to you and open. And then try to do the review without any help. And if you're getting stuck, you don't know it. You know what I'm saying? I mean, you don't want to walk in the test, and I have people tell me this all the time. I did all the homework, and I got a 20 on the test. I just blanked. No, nobody blanks. Okay, if you know it, you know it. If I ask you to add 10 numbers, you're not going to go, okay, I tried, but I couldn't do it. I just blanked. No, you haven't done enough. You've added numbers for thousands of times. If you blank on a problem, that means what you probably had was you were getting help on every single problem. Somebody was helping you, you were looking something up, you were talking to someone else, you were working with somebody, you were getting help. And you don't think of it as getting help, but what happens is on the test, you have no help. So now suddenly there isn't that little voice that whispers, remember the next step is you added 2, and it clicks something in your brain, you go, oh yeah, I add 2, and then you keep going. Now you're on a test, and you're looking at that and go, oh my God, I don't know the step, I don't know the step. And you say, I blanked. No, you didn't blank. You didn't know it, because somebody else, something external, a book, a help, a practice problem, you were always going to that and looking. And then you kept going, and you said, okay, now I can do it. No, you can't do it unless you can do it from the beginning. You can get over that creepy feeling of, what the hell? Why did I pick this major? What am I going to do? I'm going to fail. I'm not going to get a degree. So, that's my encouragement for you to do some homework. I'm talking to myself, but I'll keep trying. Okay, so, what we're going to do is solve a series of quadratic equations. And quadratic equations are no big deal. Okay? Here's a quadratic equation. Okay? I would hope to God you could factor it. And you could set each of those equal to 0. And you could solve for x. But you don't even have to do that, because you can go from here to here with your Casio. Okay? So pretty much, if it looks like a quadratic equation, your Casio will solve it. It looks like that. And that takes into account any kind of creepy numbers. Okay, now, it has to look that way. What we're going to do today is we're going to mess with the equation. It's going to look like a quadratic equation if you squint. Okay? So it'll be like this. It'll be like x to the 4th minus 4x squared minus 5 equals 0. X to the negative 2 minus 4. X to the negative 1 minus 5 equals 0. X to the 2/3 minus 4x to the 1/3 minus 5 equals 0. I'm messing with the exponents. All of those have the look of a quadratic. Okay, thank you. You guys all get this? Oh my God, is this the first time we've successfully managed to get through this goal? Holy mother of God. Okay. Finally, you've achieved what my 1033 was. So they all look like a quadratic. They all share characteristics of a quadratic. They have 3 terms. You have whatever this power is half of it. Doesn't matter here, it's 4 and 2. Here it's -2 and -1. Here it's 2/3 and 1/3. The idea is these are potentially all factorable, like this is factorable. This is x squared and x to the 1st. That tells you when this goes to factor, it splits into 2 identical pieces, x and x, what that is. If I were to factor this, it would factor into 2 identical pieces, x squared, x squared. This would factor x to the -1, x to the -1. This would factor x to the 1/3, x to the 1/3. So they all start off like quadratics. What happens is at the end, they're all solved differently, because now one's an x squared, one has a negative power, one has a radical in it. So these are the previous techniques, but the beginning part, to change from the trinomial form to this form right here, or to change to this form, you can use your Casio. So here's the deal. I want to factor this, so I got two ways to do it. I'm going to show you how to do it with your Casio first. So this would be called a U substitution. What it basically means is, let's pretend. Let's not try and make my eyeballs sore by looking at x to the fourth and x squared, because that's just too freaky. Let's pretend this problem is u squared minus 13u plus 36 equals 0. In other words, let's pretend that's a square and that's to the first power. What God intended a quadratic to be. Yeah.
13.
Oh yeah. Okay, so I have other problems. See, now you're paying attention. Now you can see I can't copy, okay? So, let's pretend that's what it looks like. If this were what it looked like, what I'm pretending, then I could put that into my Casio. And I could get two answers. So let's do it. Let's say mode equation number 3. I have 1 in front of the squared term, negative 13 in front of the term to the first power, and 36 as my constant. So my two answers are 9 and 4. So, yes? I'm saying it, and I'm just like, not even looking. Okay? That's not what I really had. That was my fluffy equation, my comfortable equation. It had nice exponents, life was good, the Casio would solve it for me. Now I have to take it back to what's really there. Those are not supposed to be used. They're supposed to be what I get when I factor this. And this puppy should be factoring like that. In other words, that x to the fourth should split x squared. So in other words, that's not supposed to be x equals 9 or u equals 9. That's supposed to be x squared equals 9 and x squared equals 4. Okay? And now I finish it. So the factoring part, or the solving part, is the least of it. That's your basic quadratic that you already know how to do. This is a substitution. I go over, I see what my numbers are, I bring it back here, and I finish it with the real exponents. So whatever this is, it splits into two identical pieces. So now I have x squared equals 9. X is plus or minus the square root of 9. X is plus or minus 3. X is plus or minus square root of 4. X is plus or minus 2. And that is my final answer. Or answer. Right? Notice that the highest power here was a 4. Whatever the highest power is, that's how many answers you can get. So since that was an x to the 4th, that means potentially I can have 4 answers. I might have fewer, but I'm not going to have more than 4. Okay? Now, do I have to do this? You don't have to. I don't do that because I can factor this just looking at it. I can say, look, I got a colors here. You say if I have x to the 4th minus 13x squared plus 36, this thing factors x squared, multiply to 36 and add to 13, that's 9 and 4, minus 9 and minus 4, x squared minus 9 equals 0, x squared minus 4 equals 0, x squared equals 9, x squared equals 4. So, I can factor this thing directly without any kind of substitution at all, because I see that it doesn't matter if I'm factoring with an x squared or an x to the 4th or an x to the 6th or an x to the 10th. As long as I can cut that in half and put each half in the front of a parentheses, then I can figure out by FOIL how it factors. But if you suck at factoring, and you were happy to know that Casio would solve these, then you need to alter the appearance slightly so that you can put it in Casio. In other words, identify something squared, something in front of the first power in this, get your numbers, but put those numbers back with what should have been in there to begin with. In other words, those were never really x's that I was going to be getting. Those were really x squared. And then finish. So this part of the problem right here is the same for every single one of these. Doesn't matter what it is. You can make a fake equation. You can figure out what what Casio is going to tell you the answers, and you bring those answers back to the real equation. But every time, this could be different. Maybe it's x squared. I want to solve it one way. If that's x to the 1/2, I solve it differently. If that x is to the -1, I solve it differently. So that's where the technique starts. So the beginning part of the problem is the same. You could literally open up the test, and for every one of these completing these quadratic and form, you can do the first two pieces at the beginning. They're all the same. And then you start thinking about, how do I solve it with a square? How do I solve it with a square root? How do I solve a negative exponent? Those are the differences. Okay.
Can I ask you a question? When
Yeah.
you punch that into Casio, the u to the second minus 13u, what did you put for a?
A is, it's the numbers in front. So A is 1, B is -13, and C is 36.
Okay.
I mean, I'm calling it a U substitution because this is the official name of what it is.
Mm-hmm.
And no matter what class you're in, if you have your Casio and this technique, nobody knows you didn't factor that yourself. Or use the quadratic formula. So you could solve that by using the quadratic formula. So no matter what kind of calculator you have, you could get these two numbers and then go back over here and put in the real x's. I'm telling you, in case you end up in your next class, and now they want you to factor. You know what I mean? I'm over that. Okay, here we go. It's a little bigger, so maybe it's easier to see. Now, if possible, you can factor that. Multiply 64 and add to 12. That's 16 and 4. Multiplying 64, add to 12. But you don't know that, let's say. Let's pretend you are not the master or mistress of factoring. So you were going to say, let u equal x squared. U is always going to be what's in the middle. And then you're going to write as your fake equation, u squared plus 12u minus 64 equals 0. And then you have a is 1, and b is 12, and c is minus 64. And then something is going to tell you, I have 1, 12, negative 64. I have 4 and negative 16. Right? And back we go. I take the 4 and the negative 16, and I go back to what I'm really supposed to be working with. They're not used. That was my fake equation to make it easier for me to stare at. I'm really supposed to have that same thing, x squared. So what I'm really supposed to be looking at is x squared equals 3, and x squared equals negative 16. So So that's x is plus or minus the square root of 4. X is plus or minus the square root of negative 16. That's x is plus or minus 2. And x is plus or minus 4i. Yes?
Question. I got the same numbers, but I got positive 16 and negative 4.
Okay, those aren't the same numbers.
Well, I mean, it's the sign. You got, like,
No, that's not just the sign. That's off by 32. From negative 16 to positive. You factored it, then you must have factored it incorrectly. You would have to have positive 16 and negative 4 in order to get positive 12.
yeah, that's what we got.
But then you set those equal to 0. And they move to the other side, and that's what causes the sign to flip. Now, the steps I'm showing you here work for every one of these with a higher power. Notice I didn't change anything. And I think this is something that students tend to do when you're desperately trying to make up your own rules. You try and find different methods. Well, if it looks like this, I can do this. I'm telling you, this is the same for every single one of these. The numbers can get nastier, the numbers can stay easier, but everything that has a higher power can be done like this, okay? X to the 4th, X to the 6th, X to the 10th, doesn't matter. All the same. Okay, ready for one more? You still give me that look. Like, I liked you, and then you did this, what the hell? I betrayed you. Okay. You should have been able to factor the first two easily. This is a little hard. Okay? And my advice is if you can't factor it instantly, move on and use your Casio, you know, because you can spend a lot of time in factoring guessing. I mean, that's what factoring is when you do FOIL. So you might as well just go ahead and do it. So I would say u is x squared. So that makes this 4u squared minus 13u plus 10 equals 0. A is 4, B is minus 13, C is 10. So I have mode equation number 3. A is 4. Remember in front of the middle term, isn't it? Okay, where the hell that came from? Is negative 13. And the constant is 10. So that's 2 and 5/4. And then I go back to what it's supposed to be.
Does it benefit us keeping it as a fraction, or should we put it as a decimal to make it easier? Or the 5 over 4?
I don't know. Do you want to factor and do stuff with a decimal?
Okay. Yeah, good idea.
Leave it alone. Leave it alone. Fractions are your friend. Remember, you have a calculator. What do you care if it's a fraction?
That's true.
Okay. So now I'm going to say x squared equals 2, and x squared equals 5/4. So that's x is plus or minus the square root of 2, and x is plus or minus the square root of 5/4. Plus or minus 2, that's it. I mean, square root of 2, square root of 2. 5 over 4, if you're not sure ever, if whatever you get here, you can just type it in your Casio to simplify it. In other words, I don't need another step in here. I don't care what these are. Don't think ahead. Whatever that is, it could be any kind of weird ass number. Go back to mode, and in this case, we're going to be complex. And square root of 2 is going to stay square root of 2. If you're not sure, type it in, and your Casio is going to tell you, yeah, that's it. Okay? And then do square root, fraction under 5 over 4. It'll tell you you should take the square root of 4 in the denominator. So now the answer is square root of 5 over 2. And by the way, if you had made that 1.25, which is the decimal version, you could have still because your Casio will give you the fraction answer. You will never see the decimal version as an answer. Yeah, everything in math is usually done in fractions rather than decimals. Okay. So it seems not that bad. Yes?
Is it important for us to check both of the answers in all these as well?
No. You only have to check if you square both sides. In other words, the same thing you were doing with radicals. In other words, if I have an equation that has an x to the 1/2 in it, and I had to square both sides to solve it, I'd have to check those. I mean, you can check just to make sure you got it right,
Yeah.
you know. Okay. Negative integers as exponents. I have no fear of this problem because it is exactly the same as the other one. What is u going to be? X to the negative 1. It's what's in the middle. In this case, x to the negative 1 is in the middle. So I say, let u equal x to the negative 1. So I have 5u squared minus 4u minus 12 equals 0. My eyes are shielded from the horror of negative exponents. I go mode, equation, quadratic. And so right here, a is 5, b is minus 4, c is minus 12. So I have 5, and then minus 4, and then minus 12. Give me 2 and minus 6 bits. Okay, back to the reality. So the reality is, it's not a u, it's this. Remember, it's all about the middle term. It's supposed to be x to the minus 1 equals 2. And it's supposed to be x to the minus 1 minus 6 bits. Now, this requires a different technique for solution. I don't have squares anymore, so I'm not going to say plus or minus the square root. Now the problem is here. You know, if it were x to the first, I'm done, because that's x. It's the negative exponent. So here's the trick to get rid of a negative exponent. You just flip over both sides. X to the minus 1 is 1 over x. So now it's x. And this is 1 over 2. This is x minus 5 over 6. Let me put in that step where I should. Well, I'm not going to see it. Well, I'll put in that step where I should. Notice I didn't lose the negative sign. It's not a negative sign that disappears, it's a negative exponent. Totally different solution. But notice, this is the same. U is the middle, rewrite it, get those numbers, bring them back, and put in what it's supposed to be. Once this is in there, now you have a different kind of solution. Because I didn't have squares, I had negative exponents. Man, you are a quiet class today. I have one more question next. So, to use this technique, these things need to look like quadratics. They need to look like something you would put into your castle. So, one of the things about this one is, it's in the wrong order. So I'm going to put it in order. Okay. Highest power to lowest power. Well, in this case they're negatives, but you know, same deal. So goes to the 4, to the 2, and then nothing. So this power is half of that power. So it's that same quadratic look. So let u be what? yeah, x to the negative 2. So I have 5u squared minus 4u minus 1 equals 0. A is 5, b is negative 4, c is negative 1. Node equation number 3. 5, negative 4, and negative 1. 1 and negative 5. Back over here. So what I really have is what's in the middle, which is x to the negative 2. So x to the negative 2 equals 1. Or x to the negative 2 equals minus a fifth. So now I have two things going on. They're squares and they're negatives. I'm going to get rid of the negative first. By flipping this over. So first I get my positive exponents. So this becomes, oops, sorry, the right color. X squared equals 1. X squared equals minus 5 over 1. Both flipped over. And now I'm back to the first one. Now I have an x squared. So in order to get rid of an x squared, you need plus or minus the square root. X is plus or minus the square root of 1. It's plus or minus square root of negative 5. So x is plus or minus 1. X is plus or minus square root of 5. I. Oh boy. Thought maybe you tried to throw that. Just hit the floor, that's okay. I'm switching to journalism. I want to work for Fox News. What's that? Here, I'll ask you guys. What's that look called with the girls who dress like little girls? No, it's called something.
What's the what?
It's like steampunk, but it's not. It's totally different, but it's a thing. They dress. They look like they're out of like Alice in Wonderland. You ever seen these chicks on campus? You haven't seen these on campus.
Cosplay.
Well, it looks like cosplay. I mean, cosplay is everything. You know what I'm saying? But it's not cosplay. It's a narrower.
Lolita.
Is it Lolita?
Lolita, yeah.
Lolita. Thank you very much. I should have remembered that from the book. Maybe. Now we'll all be doing and try and stay away from the more scientific. I'm going to teach it. No, because I have one in my 1033 class. Sits right in front of me. Okay, like the whole outfit. Okay. The pinafore, the bow, the this, the that. And every time, and I love the outfits, by the way, because who am I to talk, you know, when 20 years ago I was walking around with a mohawk and, you know, whatever, okay, so, I'm not here to judge, okay?
That's true, I want to see a picture.
Oh, honey, oh, you don't know. I had a huge mohawk, like black on the sides, white, looked like a skunk. Just all in black with the boots, the chains, yes.
Nice.
Chain, mind you. Okay. Oh no, the administration used to see me like this. We gave her tenure. I can't help it. It just happened. A little bit punk. I went to, the only time I ever broke a bone was slam dancing. And I was all geared up to go to a, I don't remember what the concert was, but it was bad. I don't remember. I don't know. Dead Kennedy, Black Flag, who the hell, okay? And I had to go to the ER in this whole outfit, you know. No MTV, and I was not into body mods, okay? I had no piercings, I had, I fainted the sight of needles. But my friends, not true. Okay, so here we are walking into the ER looking like, I don't know, the walking living dead. It was not a good scene, not a good scene. They're all frozen, so all the gunshot victims are like moving away from us. So I am not here to tell anybody, how they should dress. But it just cracks me up, and I know there was a name for it. I couldn't even drive me crazy all weekend. Because in class, apparently before I come in, she draws on the board. No, she's hysterically funny. And she conducts a little class. So I came in early the other day, and she was at the board doing something or whatever. And I was going to say, I was going to stop and go, oh, thank God, I'm always afraid we're going to wear the same outfit. I don't think that weird. But I got to remember what it is so I can have an outfit ready. Okay, thank you. Okay. No, Rita, that makes sense. But it's not sexual. It's like cosplay. What? What's a thing? No, I like stuff. I'd be steampunk if, it wasn't sad to see someone my age being steampunk. You know what I'm saying? I'm a little beyond that. You gotta make that choice when you get to the wrinkle part. It's gonna be, it's not good. Okay, so, fractional exponents. I don't care what they are. SSDD, you know what I'm saying? What's U? Middle one, right? Y to the 1/3. Isn't that how freaky it looks?
It's always the one in the middle?
Always the one in the middle. It's almost like math has some freakish logical pattern to it that remains the same all the time. It's just bizarre. Okay, so once again, it's 2, it's 6. So I have oops, sorry, I'm going to go to equation. Number 3, 2, 7, negative 15. And I have 3 halves and negative 5. And back to here. And I put in back into there what I really should have been writing all along, which is y to the 1/3 equals 3 halves, y to the 1/3 equals negative 3. And once again, I have something different. Now remember, fractional exponents.
You mean negative 5?
No. I don't know what you thought you saw. It was always negative 5. I'm getting excited. What costume I should know. Okay, so these fractional exponents mean radicals. So you could think of this if you wanted to like this. This is a cube root of y. 2 halves. And then it's a cube root of y. Minus 5. So how do I get a y out of that? Erase the cube root. The cube. So I am going to, I can do it from here. I don't have to rewrite it that way. I mean, I'm showing you this so you realize that just like, you have a square root, you square both sides. You have a cube root, you cube both sides. So this becomes y and 3 halves cubed, which you can, just do in your head, or you can actually put that into your Casio. At this point, all arithmetic hurts you, because now you have a machine for that. And this way you won't screw anything up. So you could write 3 halves with a cubed, 27/8. this would be minus 5 cubed. Would be minus 125. 2 answers. Which you should have been expecting, because the number on top is the power. That's a 2 out of 4. So only 2 answers. Same thing in the ones with the negative exponents. Even though they were negative exponents, it was negative 2 power. So I was only expecting 2 answers. But that's yet a third technique of solving. But still, here to here to here, get this, bring it back. This part has been the same for every single problem. It's the bottom part that is going to change, whether it's higher power or a negative power or a fractional power. Yes? This? I just cubed it then. Me solve it? That's good. Yeah, the first ones we did have 4. I know. Seems so long ago, but see, plus or minus. Plus or minus, that's 4. It goes by the power. This has the 4th power. So that's possible 4 answers. This is a negative exponent, but it's still only negative 2, so that's only going to have 2 answers. So, I may have lied a little bit. Not the first time a woman has lied to you, I'm sure. Because it's not just the exponents you can mess around with, you can also mess around with the basics. But don't worry. Your friend and closest companion at this point in your life, Mr. Casio, can handle this. So what's you? The one in the middle. The one in the middle. The thing in the middle this time is x squared plus 3x. Okay? Never changes. It's almost like, it's like a rule. I know, it's freakish. Math is filled with those bizarre coincidences called rules. So this is u squared minus 8u minus 20 equals 0. A is 1, b is negative 8, c is negative 20. This should look boringly familiar by this time. Okay. Go to my friend, which I could not marry in Tennessee. And I don't know, Kim Davis might marry me, my calculator. As long as we were both Christians. Is 1. Can I tell you my favorite Twitter thing right now? Is sit next to Kim Davis. Have you seen this? I swear to God, I die laughing. Okay, I'm talking to myself again. You only know. Oh, just teach us algebra. Okay. Trying to enrich your lives. My Twitter feed. Oh, God. Okay, so I have 1, negative 8, and negative 20 equals, so I have 10 and negative 2. So I have u equals 10, u equals negative 2. And back we go. Back to reality. Back to what u is. U is really supposed to be x squared plus 3x. So it's x squared plus 3x, that's supposed to be 10. And it's x squared plus 3x, that's supposed to be negative 2. yet another kind of equation to solve. But the beginning technique remains the same. Figure out what you need to change it to make it look good for Casio. Solve it, bring the numbers back. These are two little baby quadratic equations, which you can factor for Casio. If, I'll show you one of them factored, just, what the hell, pretend we know how to factor. X plus 5, x minus 2 equals 0, x plus 5 equals 0, x minus 2 equals 0, x equals negative 5, x equals 2. Here I have x squared plus 3x plus 2 equals 0. We'll go right to Mr. Casio. Although factoring 2 is not difficult. There's a rumor there's only 2 numbers that multiply to 2. I'm just saying. Okay. But in case you're not the trusting type, 1 in front of x squared, 3 in front of x, 2, that complicated one. Negative 1 and negative 2. So, I'm showing you what you would be showing me on the test. I don't need to see a lot of factoring steps and all that. I need to see that you understand the structure of how this works. So what you understand is something that's as messy as this, you change into something nicer, you get those numbers and you bring it back to the mess. And then you continue on. But, this is sufficient work right here. Make it equal to 0, because no matter what you're going to do, factor a quadratic formula, completing the square, if now you become so fond of it. Yes?
Which one was the answer?
Pardon me?
Which one was the answer?
I couldn't hear you. Which one was the what?
The answer.
Oh, all 4. Because I have x squared squared, that's x to the 4th. If I were to multiply that whole thing out, God forbid, I'd have a 4th degree polynomial. If you did multiply it out, by the way, you couldn't factor it. It is factorable, but if you want to learn how to factor that, you have to take the next algebra course. Pre-calculus. Where hell really shows up for a visit. Okay. One more. Yes. Go back. Second. And now you're going to be able to open. I mean, I could send them as PDF files, but I don't because it's better to have them as Word documents. That way you can even type in your own comments if you want to. Put a little text box. Knock yourself out. Okay, here we go. For one final time. What's you? And I don't care what kind of weird ass thing is in there, barking dogs, fractions, I don't care. Okay, so that makes this u squared plus 4u plus 3 equals 0. A is 1, B is 4, C is 3. And when I type that all in, I'm going to get minus 1 and minus 3. Right? Okay. I take that back home. So now I have 1 plus 1 over x equals negative 1. Here. And 1 plus 1 over x equals negative 3. So, how do I get rid of that x in the denominator? Multiply by x. How would I get rid of 5 in the denominator or 10 in the denominator? Doesn't matter. Just multiply everybody by x. So this will multiply here, here. So I'm left with x plus 1 equals minus x. That's 2x equals negative 1.